Okay, I think we're recording now. So yeah, so anybody joining us, Glass, Greater Lansing Area for SQL Server. This is our October 2023 meeting. We have Aaron Cutshall, SQL RV on the Twitter and the HTTPs. And Aaron, understand recently got a PhD, is that correct?
Well, it's a DHA. It's a
Oh,
Doctorate of Healthcare Administration.
oh, okay. So sorry on the confusion
Nah,
there.
it's all right.
We still get to call you Doc.
Yep.
So that's the important thing. All right. How do you want to handle questions, Aaron? Save them to the end. Take them in the chat.
No, just anytime. Because to be honest with you, this session isn't as in depth as some of the others that I have, so it probably won't take that long.
Okay.
So the more questions, the merrier.
Okay. Sounds good. I'm gonna go ahead and turn my camera off and mute and let you take it away.
All right, is my screen visible?
Yes, it is.
Okay, cool. So I appreciate Jeff reaching out to me and inviting me to speak. You guys selected the XML Xtreme and learn how to query XML. One thing that I will say about XML is that it's been around for a long time, and it's going to be around for a long time, no matter what the JSON pundits say, because it has a lot to offer and still does to this day. So just a little bit about myself. If I can get my clicker working, there we go. It's probably wondering who I am. I've been here before, which I appreciate, but I am SQL RV, as we talked about earlier. I do go around presenting SQL Server and database presentations in my RV. I am an enterprise data architect at Health First, which is a health insurance company for New Yorkers. They have an office in, of course, New York City, as well as in Lake Mary, Florida. Uh, Probably have more people in Florida than they do in New York. Uh, but that's where I work out of, even though I am in Southern Utah. And I do go around giving a lot of presentations. SQL Saturday. Uh, I'm going to be back at Summit again this year. I've spoken also at Enterprise Data World and also at the Postgres conference because I hate to tell you, Jeff, but SQL Server is not the only database in the world. um, I got a Bachelor of Science in Computer Science at Ball State University. So since you guys are from Michigan, you're probably a little more familiar with it. And then I got a Master of Computer Information Systems in at University of Phoenix, back when the company that I worked at sponsored me for it. But when I got into healthcare, I decided to go back to school and got a master's in health informatics, which is a great blending of healthcare and IT, or information. And I didn't want to stop there, so I went ahead and got my doctorate of healthcare administration from the Virginia University of Lynchburg. So yes, that's over with. But I've been doing this for over 35 years. So there are times when I get really frustrated when I think that I just can't go through another day, and then I think about Professor Stephen Hawking and all the challenges that he's had. And I love this quote because he says, "However difficult life may seem, there is always something you can do and succeed at." And I thought he was a great example of that. So I think whenever we each get a little downtrodden by the day-to-day grind, these are things that we need to remember. All right, so we're going to talk about some background info on XML, what it is, and then we're going to talk about a use case where we can actually query XML, uh, and how we're going to open XML documents for queries, and also we're going to take a look at using some of the simple structures that are in XML. We're going to also talk about how to join XML queries with SQL Server tables so that you can get the best of both worlds. And then we'll talk about also querying complex structures within XML. And then we'll also have nested structures. And then we'll cover some query optimization before we close. So some background info on XML. It's really called the extensible markup language, and it was developed as one of the branches and one of the flavors off of the standard generalized. I can't even talk today. Generalized markup language, which of course HTML came out of, and so it became standardized in 1998. Originally, when they had document standards, they created what they called the document type definition and to enforce the structure within XML. But because it wasn't expressed in XML itself, it was somewhat limited in what it could do. And so then they came out later with the XML schema definition in 2001. And it actually is written in XML itself. And it also adds namespaces and other features that are necessary in today's operations. XSD version 1.1, released in 2004, added some new things, plus fixing a few other issues. And what really surprised me is that at the time, it's still not widely adopted. A lot of references are still made to version 1, but 1.1 is still the predominant version that's used. So XML, like I said, it's based similar to HTML, and it uses data tags that are in brackets. But unlike HTML, the tags will actually tell you what the data means, not just about how to display it. So we are still describing information and the structure of that information, but instead of HTML being more of how you display the data, this tells you how it's structured and how the content is the definitions of the data within the content. It does not have to be constrained by a schema definition XSD file, but I always suggest it because otherwise you'll get some really squirrely XML. There have been a lot of arguments, especially since JSON become really popular, that XML is too complex. And I can say that it can be complex. It really can be, but also so can JSON. It's just that the rules for XML is based upon flexibility, and they're really pretty simple rules. And it allows you to build upon those rules, and that's what builds up your complexity. But it's also where the power of XML shines through, is from all those various combinations. Now, I've got a particular use case that I'm going to show. It's very simple. Now, as I mentioned, I'm in healthcare, so most of my examples tend to relate to healthcare. So I'm going to have a situation where I want to share patient data between two different systems. It's not like I can go through and connect to it and insert data into a table or anything of that nature. These systems are completely separate, so I want to send them a system agnostic data. That way I don't have to worry about whether it's SQL Server or Oracle or it's a Hadoop or whatever. I don't care. This is the structure of the data. And it also allows for requests for information about a specific patient. So the examples I'm going to show are not as explicit as this whole use case, but it'll still give us an idea. Some of the requirements in this use case are that the message file must allow for multiple receipts. Think of like an email where you can take an email message and send it out to multiple people. We also may need to present multiple patients at a time and still keep their data distinct from each other. And we also need to handle various types of data, such as their hospital visits or encounters. And of course, there are clinical data such as their diagnosis procedures and lab results. And we're going to also use the standardized vocabulary systems. Healthcare loves their coding systems, and they're really very useful and very flexible. And so that's why they're pretty pervasive. And different coding systems serve different purposes. CPT, for example, is about identifying procedures. LOINC is about identifying lab work. and the all right, then you have the diagnosis codes, that will help identify what your diagnosis is and diseases are. So the solution, well, we can make, well, we're going to make this again, like I said, really simple, but we can do a really complex use case scenario if we wanted to with this. But I don't want to overwhelm you just for this hour.
Aaron, just a quick question. You were talking
Yes.
about diagnostic codes in hospitals and the like.
Yep.
Do they use the same diagnostic codes that they use in the EDI?
Generally, yes.
Okay, thank you.
So yeah, the the ICD codes for the diagnosis, yeah, they're still the same. There are different versions of those. Like right now in the U.S., everyone should be on version 10 of the ICD diagnosis code system, and that's to help improve the data sharing amongst the different entities.
Thank you, sir.
So the within the schema for this patient message, we're going to deal with two main bodies of structure. One of them is the elements, which is the main components within an XML, and then the attributes, which are the characteristics of that element. And then, of course, we identify the data types that we want. And these are the ones that are built in by in XML and enforced through the XSD. And these simple types can be combined together to create even more complex types or even data structures, if you will. And there are extensions which we can add even more complexity to it if we wanted. We can also then group things together. There's an element called, or not an element, but a type called a sequence, where it allows for a series of elements within that sequence. And you can classify that as a data type. There's also choices where you can say, I want one of these series of choices depending upon some criteria, almost like you would like a case statement.
So would the sequence be like an identity column then?
Kind of. It's more like a, here's your first item, here's your second item, etc. So
okay.
let me show you an example.
All right, thanks.
So here is actually, let me start with the message here. So here is I did want to start with the schema. All right, so here's the schema. I am defining a simple data type. This one, I actually can give it a name. I'm calling it an enumeration, yes, no. It is based upon a simple data type called a string, and it has value of just yes or no. The interesting thing is that whenever someone tries to put a different value in there, like maybe, then the entire XSD will prevent it from passing validation because of that error. So we could define other types in here so we can get pretty specific. Like for action types, I only want values of request and response. And this helps, again, to make sure that our data is clean, that as we build these messages, as we use the structure, it's going to have the correct tags necessary for it. You can think of this as being like your lookup values in another application. And then, of course, I have things like the states. I listed all the states here. This is also a good example that you can put comments in your schema. And here's a complex type. Now, in this complex type, I'm saying I want this to contain multiple parts, multiple attributes. This I can use because of my name. I'm going to have several parts to my name. And I can specify not only the data type, but also what's required and what's optional. So in this, I can say for a name type, I am required to have a given name. So I have to have at least some name. The rest of it could be optional. Same thing with an address type. I can specify exactly what fields I need in that address type, what their data types are, and whether they're required or not. And notice, like, for example, here on state abbreviation, I made use of the data type that I created earlier, called enum state type. So it can build upon itself. Here's another example of a more complex type. This participant type is based upon a sequence. This sequence means that I can have more than one of these occur within a participant type. And in that type, I can have a name. And this name, I'm saying that I want it to occur at least once and no more than once. So basically, I have to have one value. With a primary address, I have to have at least one, and again, one. Here's one that is optional for mailing address. I don't have to have a mailing address, but if I do have one, I should have only one. And then in addition to that sequence, which has these elements to it, then I'm adding to that an NPI, which is a National Provider Identification. So I can build these additional complex types. Here's one that's even more complex. I'm taking this diagnosis type. And what I'm saying here is I'm going to build an extension. I'm going to take the base record type that I defined right here, and I'm going to add to it a diagnosis date. In any other case where I use a base record type, it won't have diagnosis date, only the type where I use diagnosis type. So I think of that like like an object-oriented programming, where I have my class, and then I can extend that class and for other uses. Same thing here for the procedure type. I'm using my base record as my basis, and I'm adding to that or extending it to include start date and stop date. Any questions on that so far? Cool. So let's get to a really complex one. Let's talk about the message itself. In this message, I'm defining a sequence, which means that I'm going to have multiple items, and I'm going to have an element for the sender, and it's a participant type that must occur, minimum one, maximum of one. And the recipient is even more complex because I'm taking that participant type and I am extending it to copy only to an additional field. Because the recipient, you have to have that person, and it always goes to that one. And then the participants, think of them as being either a carbon copy or a blind carbon copy, whether they can be there or not. And then we also identify in this structure this patient, and this patient is going to occur multiple times. So we have at least one, up to however many we need. And we're going to have that being a sequence of their name, their primary address, mailing address, and then we're going to create a choice here. And this one can occur multiple times. So this can be multiple of these, and it's going to be either a diagnosis, a procedure, or a lab in any order there. And then of course the birth date, and then the medical record number, or MRN. And then we'll also finish that sequence with some information about the message itself, such as the date, time, the action that is to be performed, and the purpose of the message. So let me get back to here. And
in my mind, I was designing tables for all of this.
Exactly. Yep. And yeah, I can see you doing that. Okay.
Yeah, that's kind of where I was. I'm looking
And
at
you
that
can think
going,
you can think of it like that. You can think of those all of those. Let me come back to here. You can think of all of these right here as being like table structures, is like DDL, if you will.
and then not null defines itself
Yes.
from the,
Exactly.
is it one in one, or is it one in, many?
Yep. Exactly. And it's interesting you mentioned about tables, because we're going to come back to that when we do the another demo.
Hey, Aaron, real quick, do you see on your screen that you're sharing where it says like teamsmicrosoft.com is sharing your screen and the hide button?
Yes. Oh,
See if you can click
oh,
that hide button.
I see.
Perfect.
I thought that was only for me. Sorry. I didn't know you
Nope.
guys could see that.
I kept
Thanks
trying to
for
click
pointing
on
that
my
out.
side and going, why can't I click this? Oh, it's Aaron's. Crap. Okay.
Okay,
Okay.
fair enough.
Carry on.
Okay, so now that was the schema definition. So now we're going to talk about what the file structure is for the message itself. So the schema, when I go to process it, it's going to validate a few things for me. It's going to take the structure of the message, make sure that it conforms to how we built it, how it does, does the message fit the requirements for the message? Do each of the parts within it fit the definitions of those parts that we did, like for the name, etc. Do the sequences and choices make sense? Are they in the proper place? Do we make sure we have all the occurrences, whether it's a required field, whether it's a min occurs one, or max occurs is one, or unlimited. And then we're also going to take a look at some attribute enumeration, make sure they're the correct data types that are in those choices, and also the regular data types like dates and string and integers, make sure that those are appropriate.
Excuse me, Aaron, can I ask a question?
Yes.
If something doesn't meet hey, this has to occur once, so say there's, this is healthcare, so let's go to what it's really about. Let's say there's no billing address.
Uh-huh.
Will the person's message not get formed, or will the whole XML document not get formed? Like, let's say that you and I were about to be formed in an XML document and we each had one message, but I didn't have a billing address.
Right.
Would it be me that's not included, or would it be you
No, it
and
would
I
actually,
that's not included?
the whole message would have to be valid for it to work.
So your message
So
would have to be valid and my message would have to be valid. So I would be excluded, you would be included.
no. What I mean is that this entire file,
Okay,
because
got it.
it processes the whole structure at a time.
Okay,
So even
thank
if one part of it is wrong, it's going to fail the whole thing.
Okay, thank you.
Uh,
That's
and one
good.
of the things, yep. And one of the things about XML is that it depends on how it's implemented as to what will be done with it, as far as what type of message will be shown. Um, Different applications, like SQL Server has its own rules for what's going to happen when an XML fails its validation. Other systems could have different rules, but it's all based upon that schema validation. So when you go to process this in SQL, there's also some arguments that you want to pay attention to, such as if you want verbose messages, so you get the full tags and descriptive names. Um, I like to make my XML documents fairly well named. Of course, you could use names like A and B. I apply the same rules to it like I do for aliases on tables in a query. Make it meaningful, because having a few extra characters doesn't hurt anything. Because the concise versions, they can be really difficult to read. I have seen some really obscure XML. And I ran across the other day where somebody was having this contest about, they call it a SQL golf. And it is like, how small of a query can you write in as few characters as possible, which of course they ignore, you can't have white space and stuff like that. But they would condense it to as little of a string as possible to make it functional. And I remember back in the days, in the 80s, when there was this contest that was going on about obfuscated C. How obtuse can you make a C program? And I don't think that really highlights anyone's skills at development in my mind, because that's great if you can do it and it works, but that just means it doesn't mean anything to anybody else. So let me show you the,
Maintainability does matter.
yes, it does. All right, so let me show you the message now. Now that you've seen the structure of it. So I didn't create a lot of different messages because I wanted to show different components of it. And of course, being HIPAA compliant, I had to come up with some fake names. So you'll see where I derived a lot of these names from. So here is my main message data type. And I am specifying here is my schema file to validate that against. And then in that message structure was my date, time, my action, and purpose. Now, let's say, for example, current is a valid term for a purpose. But if I made a typo in here, if I just, like put an X there, for example, and I process this, and it would come back and fail because that was an invalid purpose value. It didn't pass the enumeration for purpose. So along with that sequence, I can specify here as my sender in that message, specify the NPI, and it has a required name structure. It required me to have a given name, but it didn't require me to have a family name, but I had it anyway, so I went ahead and put it on. And then the primary address. And then here is the recipient, their national provider identification, name, and address. And this one had actually multiple recipients. So here's another recipient as well. And then after the sender and recipients are specified, here are the patients. And notice we have multiple of those. And what I did is in some of these, I gave different information. Obviously, the required information is there. For example, in this one, I have a primary address and a mailing address. In this one here, I had only a primary address. Here, I gave a diagnosis. I didn't have to give a diagnosis. I did, just like I didn't have to give a procedure. But obviously, it doesn't do any good to send over patient information with, oh, yep, here's the name and address, and that's it. I'm not really telling you anything about the patient, but it's a patient. And so I can identify, here are my diagnoses. Here's my, the date involved, the code type. Like I said, we should be using ICD-10 by now, but some systems still have ICD-9 and older data. And then there's the value of that code and its description. And then here are the procedures that were performed for that patient. Because these were SNOMEDs, I can tell that these were laboratory codes. That these were procedures performed to be sent to, I'm sorry, not laboratory, I'm thinking it's LOINC. These are just specified in SNOMED. They could have been specified in CPT as well. Here's another example where I have a couple of diagnoses, and I have a laboratory that was performed, and that laboratory has results. And then here's another patient who has a diagnosis, a procedure, a laboratory, and a whole bunch of results that came back along with their values. And some of these laboratory values could also include comments in those results. And then just to show an example that even though I can have multiple results from a single laboratory, here I have a laboratory that doesn't have any results. Any questions on that so far? Okay. So this is just basically the structure of the data. This would be the message. So pretend that here I am, Dr. Cutshall, sending this message out to a hospital, for example, or a hospital sending it to a doctor's office, so they have the patient information. So let's go see how we can use this. When reading from XML, there is an attribute called the nodes method that is used to then shred the XML. And when I show you the code for that, it'll make a lot more sense. And then it allows us to identify each of the nodes that are mapped into a new row. This is how we can get into the table column mode within the X query. There is a value method that it gets the value from an XML instance. So instead of the structure of that record, it's the actual value itself. And this would then be mapped into what you would consider to be column data. And we can also use XQuery to give an subset expressions to look at different parts of the XML tree. So we can look at just specific elements and attributes. We can also put conditionals in that in the XQuery to make more complex queries. So let me show you that one. Oops, went back too far. Where is my? Here it is. Oh, bring it up over here. Okay, so I decided to use Azure Data Studio so that I can show you how this is built. So I'm creating a whole bunch of tables. My first one I did was to create my XML files because I want to store my file in once. And then, Jeff, as you pointed out, here are a whole bunch of tables. So here's my patient and my patient information. Here's the diagnoses, procedures, laboratory. And you notice that we have references back to, based on the row number and the MRN back to the patient. And then laboratory and lab results. So I created those tables. Now here's where the fun comes in. I have a file here on my C drive, which is the patient message. Now, as we know, if the SQL Server can only see files on the server itself. So that's why this is a lot more difficult to work with, because it's not like I can take it from my laptop and then load it into my server that's housed somewhere else. So here I create my command statement to be able to do a bulk load of this XML into my my value here. And so I'm using the open row set and specifying the file name. I'm executing this dynamically as an executes SQL statement. And it's going to put the output into this variable called XML file. So that I take that XML file, which is the entire contents of the patient message file, and I loaded that into the table called XML files. And I'm going to reference that later. So now I want to query that XML. Now I could query the file itself. I can query the record in the table of those files. It's the same difference, just a matter of how you want to query it each time. For my purposes, I found it easier to put it into a table so that I can reference it multiple times. Now, one thing I did find out that date times are stored a bit differently in XML than what you would expect in SQL Server. So for example, let me go back to the document. And here's an example of a date time where it is the date, has the T separator there. Oops, didn't mean to do that. Has the T separator and then the time itself. So that's how XML references a date time. Well, that doesn't really work in SQL Server, so I had to do a replacement. Take that T, replace it with a space, so then I can cast that into a date time. And then when I take the value of the action and the purpose, and I cast those in, because say they're both varchar 16, because that's the data type of the table. And so I can query those. And then as you can see, I can get the results. There's the date time and the values of the action and purpose. Now, just getting it as a select statement doesn't really do us a whole lot of good. What is more helpful is if I can put those into tables itself. But before I show you that, here I can query again from the XML files, and I'm going to get some information upon who sent the message and their NPI, so that I can grab those particular names and then that sender information, and I can find out that Leonard McCoy, and this is his NPI, is the one that sent that information. Conversely, I can get a list of the patients. Now, these previous examples all showed only one row, but as you can see in the patient file, go back to here, we have many patients in here. And so now these are like individual records, if you will. So I'm going to say, get me a list of all those patients, including their birth date. And of course, I cast that as a date. And one thing to remember that by default in XML, just like it is with JSON, things are stored as a string because it's a text file. So you have to do some conversions on there. But so for the date, I get that as a string, and then I cast it as a date.
Just a quick question, Aaron. This is something that's always killed me. What's the ... mean?
That's a good point. Okay, so notice this path here. I'm starting at message, patient name. So what that means, you get back to the top. So I'm starting at message, and then patient, and then name. So that tells me I am looking specifically at this record right here. Now in the query, go back to here, by using ... it's, think of it like you would for a directory tree. If I make a reference to ... that means I'm at the same level. If I make a reference to a dot, that means I go up a level.
I thought dot was same, ... was parent.
Same idea.
Yeah, I got it backwards. Sorry.
Okay.
But what I'm getting at is that here within this patient message, patient name, I'm referring to the element in there of birth date, the element of, oh, I'm sorry. You know what? I know why I did that. In this message, for the same level, I'm getting the given name and the family name. But in the level above it has the MRN and the birth date. So let me go back to here, my file. So here I'm looking at, sorry, at patient at this level right here. So here's my name, but I'm going to get the date of birth and the MRN. So I go ... up to the previous level and get the birth date and the MRN.
So the ... is like a pop up.
Yeah, like a pop up. So because when I specified in the query that I am doing this at the message patient name level. Now I could have just said I'm doing this at the message patient level, and then I could get MRN at that same level and birth date at that same level. But then I would have to specify here that I'm going to go down to the name. I would have to put /name in order to get the given name if I did it like this.
Hey, Aaron,
so it's 6 to 1, half a dozen of the other.
Okay, and so my other question is the @ is for an attribute, not an not an element, correct?
Correct.
Okay.
It's for an attribute.
One other question, is there any such thing as a wild card? What I mean by that is, let's say I have a hierarchy and I don't know the structure of it, but I know that a particular attribute exists. Let's just, for example, say it's name, and I don't care where the name is in the hierarchy. I just want to get name. Is there any such thing as a wild card to do that?
There is. You can skip a level in the hierarchy. The only thing I can think of at this moment is that you can say, well, I know that it's going to be at the 3rd level in the hierarchy, and you can grab it from there based on the name. I don't know off the top of my head. You have to forgive me. It's been a while since I've worked as much in XML.
Yeah.
but I can't remember how you would specify at any level, give me an element, or I mean, give me an attribute of that name.
And the reason why I'm interested in that is because you have execution plans, and one of the things that shows up is which statistic was used. And one of the problems with statistics is you end up with a bazillion of them, and if you set trace flag 8, I think it's 8666, it will show all the statistics that were used, and that would be really helpful to, collect those statistics and say, yeah, we use those statistics, and then when it comes time to actually rebuilding statistics, you could say, okay, we didn't use these other statistics, don't rebuild them.
Right.
That's where I was going at with that. So
that makes sense. Oh, no worries. But talking about statistics, that 80% of all statistics are made up.
Well, he means table statistics.
I know.
I also found out that you can use statistics to lie, but you have to have statistics to tell the truth.
Yeah. That's true.
What is it, Jeff?
Okay.
Liars, figures lie and liars figure.
Yeah.
Yeah, that's the one my grandma told me.
Yeah.
Yeah.
Figures can lie and liars figure.
Aaron, question.
Yes.
With Xquery, is it better to go after the nodes at the level you're going to use and then pop and push in the value clause? Or is it better to go after the lowest level and then pop up?
Directionally, it doesn't make much of a difference. The rule of thumb that
parsing of the edge table under the hood.
Yeah, it's pretty much the same, but because it's all a frame of reference. What I like to do it as when I do the node at the level where I'm going to get the most of the records. Like say for example, if I didn't care about the birth date, then I have more fields at the name level that I want to get than I have above it. So, but if I was getting more data at the value above it, then of course I would get from there and then go down to the lower one. It's all a matter of preference. One advantage is that no, never mind. I started to say something wrong. Never mind. But I mean, we already know because this is at that name level. We know that this dot is really at the patient level because it's this one level up. But the point I was going to show you is that you can get obviously multiple records from this. Now, one thing I want to point out too, and it's probably in my notes later, but as much as this looks like it's a set-based method, it's not. Even though it's a single query and it returns, multiple rows, XML, it's a function that's being executed. And so it's not a, I should say, the friendliest function around it, because it's working with a file. It can't do things in a set-based manner. So you just have to keep that in mind. And I say file, even though I'm actually querying this from a field. It's called XML data. It's still
a blob.
A table. It's still a blob. Yeah, it's in these files, and I'm taking the data from that, and I'm using it. So it still has to parse the text. So it's still not set based.
So it still has to hopefully go out to the to the lab data. Hopefully,
yeah,
if they were forced out of row, go out to the lab data AU, read it, parse it, create the edge table, and then query the edge table, right?
Correct. Yep.
Okay. Thank you.
So that's why one of the things I like to do is load it into tables as quickly as I can. And so as you can see now, I've got data I'm going to load into my patient table, and it's just a simple, put an insert on top of that, do my select, and getting it from my XML files, which retrieves my my XML data, and then I cross apply that XML data dot nodes so I can get my message patient name information. So load all the information I have about that patient. And I just saw a typo here. This is supposed to be middle name.
And just in case some people are confused, Ed and I have been talking about edge tables. And what an edge table is, it's actually an adjacency list that the XML converts to behind the scenes and uses, you know, it goes through it just like an adjacency list hierarchy behind the scenes.
Right. Yep, makes sense. So in that, I go ahead and process this, and it loaded all 4 of my rows. So now when I select from my patient table, I've got my data. Now notice that I didn't have middle names for some of these patients, so that was okay. They were allowed to be null. Okay. Now I'm going to load their diagnosis records. And then, in fact, you're probably wondering too why I put the road number in here. It's just to keep track of what the order that the records came in, because I actually make reference to that here. Notice that as I load the records, I want to make sure I get for each of the patients. I want to get their data that's appropriate for those patients. So I'm going to get all the diagnoses. I'm loading them all for every patient in here, not just for each patient individually. And so I can go to the message patient, and I'm specifying based upon the SQL column what that patient road number is, and to that patient's diagnosis. So then I can go and get all of the patient's diagnoses at the same time. And then same thing here for diagnosis. Or I'm sorry, here I'm showing the diagnosis. And notice I keep the row number for this is what it is from the patients. This is the patient's row number. So I'm using that kind of like a surrogate key, if you will. Same thing here. I'm getting the procedures. Similar to what I did for the diagnoses, I'm getting all of the information at the message patient procedure level, specifying which patient I'm referring to based upon the patients in that table, and loading all of their data and converting it, the date times, integer values, and character strings. And then this is all of the patient procedures. Similar thing with the laboratory. I'm going to load all of the laboratory requests, and I only have 3 of those. And then I get the results for all of those laboratory requests. So it's kind of interesting that I can cross-apply this XML data and with the patient information and with the laboratory data that I loaded just previously, so that I can get all of the data correlated together. And so when I look at the lab results, here is for my lab number, here are the results itself, their descriptions, and they're for the individual patients and their code values.
So basically that was like an outer join?
Yeah. Yep, exactly.
Okay.
So now I've got all the patient data loaded.
And when you get data like this, you typically load it into OLTP tables. You don't leave it as XML and then create when
Correct.
you need it. You
Right.
use it as a B2B type thing, and you load it into real tables, correct?
Yep. That's what I do, because it's not efficient to query XML directly, and to keep using that as a data source. You can, but just because you can doesn't mean you should.
Can you please beat that
Amen.
into my boss's head?
Amen.
Yeah.
Every single stored procedure, we have client configurations and the like.
Yeah.
And he actually reads the client configurations from the XML every single time instead of, instead of
that's a
having
lot
it
of disk
into a
IO.
table.
Yeah.
He stores the
Unnecessary.
XML in tables. Good
Yeah.
Lord.
Unnecessary disk IO, definitely. So again, I told you I had this down here further. XML is not set based. And so the functions process for each row of output. And so in my mind, they work very much like UDFs. And so just because it's set based doesn't mean it is.
Well,
and so I
the
prefer
execution plan will tell you, yeah, it's worse than UDF.
Probably.
Yeah, thank you.
That's why I extract the data to tables as quickly as possible, because then I could do true set-based operations. The other thing I like to do is filter using the XQuery instead of the where clause. For example, I'm going to show you one that I've seen some people do in this. Okay, now I do have a where clause here, but that's just because I'm filtering out things for, for this XML files. But I have seen people that would take criteria, like for example, these the row numbers, and like which patient and which laboratory result, and they will actually put that in here in this where clause. Well, this where clause occurs long after all this XML data has been pulled in. So why pull it all in and then only to filter it out later? So do as much of your filtering in your criteria in the XQuery statement as much as possible, because then this statement can be far more efficient in getting the data section that you need out of XML, instead of having to get all of it, spend all those cycles getting all those extra rows, and then you filter it out and throw them away.
But Aaron, even if you filter it with XML, I'm sorry, with XQuery, don't you still have to read all the labs and then parse all the labs and then
Well,
filter all the labs in XQuery before you return it to the, that's all
that's
done in the from clause.
that's true, but see, but that's where this comes into play. And this nodes operation, this nodes method, that's what it does. It will do all of that work in its system offsite, basically away from the SQL processing. Excuse me. That way, you don't have to bring in a bunch of extra data, have it fetch more data than you need, only to then throw it away. Make sense? Just like you would you would want to put as many filters in your from statement, your inner joins, etc., to filter that data from here before it gets to the where clause. Because I've seen people that have, say half dozen tables that they're joining, and they'll put minimal criteria in their on statement, and then put in their where clause, they put a whole bunch of filters. Well, that's after all the data has been fetched, that it then filters it. So put that criteria in there. If I know that L is going to have some additional criteria, put it here. Filter the data first, so you
You're
don't
saying
bring it
filter it in
in.
the from clause rather than the where clause, because that
Exactly.
gets fired first, right?
Exactly. And that's essentially the same thing we're doing here in the XQuery with XML. We're filtering in the where clause, or in the from statement, so it doesn't get to the where clause.
But does that actually get done? How do I put this? It still has to read all the labs and do all the filtering and everything else with all the string parsing and all the edge tables, right?
Yes, but it doesn't have
Okay,
to do all of this stuff
fair enough.
to do
Okay,
that.
thank you. Thank you.
Because you got to realize each one of these values, these are functions. Okay, It's doing a function
Mhm.
to get out of the results to get this information. Because what this section here does is it says, all right, here are the nodes that I'm going to return back to this query. And then I'm getting these nodes here. So I've filtered the nodes, put in the criteria ahead of time so I can restrict the number of nodes that I'm returning. Okay.
Okay, I think that makes sense. Thank you.
Okay.
Thank
Cool.
you.
Yep. Okay. So XQuery. There's a whole lot in XQuery itself. It's got its own language. There's a whole lot that you can do in there. It's pretty cryptic, but you can do conditional logic loops. You can actually establish variables. It's very compact, but and some people say it's easily understood. I think if you look at the logic of it itself, it is fairly understandable, but it can be very obtuse once you put it all together. Um, it can't be used by itself. It's not a separate standalone language. It's not like I can go, oh, here I have an XML file. Let me do some X querying on that. It doesn't quite work that way, especially with SQL Server. And that's what the functions that are available in SQL Server allow you to do. So you use it in conjunction with the other development languages. And so now you're probably thinking, would you like to know more? This can get kind of overwhelming. Many years ago, I did a lot of work in XML with XSDs and with SQL Server. I built a system that was taking clinical quality measure definitions that were in XML, and it was transforming those into stored procedures because they were direct. It wasn't data per se, but they were. It was a way of describing how a measure was to be calculated, and so it was structured in such a way that I could transform that into a stored procedure of SQL statements. And it worked really fast. The nice thing is that with an appropriate editor to help people build the XML files, they didn't have to be programmers. Clinicians could go in there. They know better what the diagnosis codes to use, et cetera. And they could go in and describe these measures and put it into the system. It would compile it to store procedure, execute it, and get the results. And that store procedure was repeatable because these measures were calculated sometimes multiple times a day as patient data came in. So let me just close. Like I said, I barely scratched the surface. There's a lot more to it. Because of the simplicity of XML, it allows for some very complex statements. It sounds kind of like an oxymoron to say that something so simple can be so complex, but it's true, and it's the way it's built. And that's when I built my clinical quality measure definitions. They were very simple. It was a very simple structure, but because of that simplicity, it allowed a lot of complexity and expressiveness in how measures were going to be created. So, that is just an extension of XSD itself. So what I gave you were like really simple examples and explanations. So if you really want to look into it, I can recommend some books. I've got some other things you can look into. For example, recursive definitions are possible in XML. Not that I really recommend it, but it's possible. You can also have multiple schema definition files that are then brought together into and have one file that's like an include statement where you go in and fetch all these different parts. Because I had one that did just my enumerations because I had so many of them and built so many simple data types. I put that all into one simple file so that it would be easier to manage. And then I put all the more complex ones, all the major elements and complex types into another one, and made it easier to edit and to keep track of. You can extend this to do all sorts of things if you really wanted to. So here are a few helpful resources. I found this book, XML Schema, to be really useful on Riley. This one is one that I have right now on my shelf. And then XQuery was also really helpful. I did not myself use XQuery as much because I was just grabbing the structures in a more simple fashion. But if you really wanted to get into the nuts and bolts of it, Priscilla Walmsley has a great book on that one, and I have referenced that one. Any questions?
There's something online for XQuery that we could go look at instead of a book.
Yes, there is. I don't have one off the top of my head, but you can Google it. In fact, when I started working in XML, I did most of my stuff through, a lot of Googling, and then I found a few other books that really helped. In fact, I've got one. Yeah, let me grab it real quick here.
Who's that fella, Jeff? Mark?
Yeah, this
Crown,
is probably.
I think it was.
I'm
Yeah.
sorry. But yeah, I referenced one. I don't know if you can see it. It's called XML Schemas, and I found this to be extremely useful. I sometimes could find things in this book faster than I could online, and I got it for the expensive price of 99 cents at a used bookstore, and that was the best 99 cents I ever spent.
Some good things never change.
That's for sure. But I would appreciate. I mean, if you want, the slides are available, and so you can get access to the examples. And I'd appreciate some feedback. And there's my contact information. But you can find me on SQLRV.com.
Very good. Excellent. Thank you, Aaron, for that. I don't see a lot of presentations on XML, so this was a good one to have.
Yeah, it was probably a good refresher. I had to forgive me. My allergies kicked in today for some reason. That's probably why I sound all plugged up.
Sounded
But
good to me.
I had to review this quite a bit, just to refresh myself on it because I haven't used it in quite a while.
Yeah. Still lots of it out there. Ain't going anywhere, like you said.
No, it's not. I still run across it all the time. And in fact, one of the arguments that when people were first, pushing JSON, they're saying, "Oh, it's you can represent data in a smaller segment." It's like, okay, but if you can't enforce it, if you can't standardize it, then what good is it?
Mm-hmm.
But now they come out later with schema definitions for JSON. They just copied after what XML has been doing, and so it's essentially the same thing as XML, just a different structure, different way of looking
It is
at
the
it.
same thing under the hood, just different
Yep.
syntax.
Different syntax. Yep, exactly.
Mhm.
And I have seen some pretty verbose, complex, difficult to read JSON as well. So it didn't really solve any problems.
Yeah.
Except tag bloat.
Yeah.
Sorry, Ed?
Except tag bloat.
Yeah. Well, and that's the thing with the tags. People say that they don't like that, but in JSON you have to label things a lot more. And tomato, either way.
Mm-hmm.
But I like the way you can do things in XML, and it is clear at least. JSON doesn't have the concept of an ending tag, but when looking at the code, I know that, oh, here, I reached the end of a particular patient record. No argument there.
Yeah, Jason has another curly brace.
Yeah. And that curly brace could belong to anything.
Uh-huh.
So it's hard to tell
Yeah.
if you
You're not
don't
going to
have
get
it.
any arguments out of me.
Hey, Aaron, I have a quick question.
Yes.
What about 835, 837 files to use it in SQL? Is there any
Yep.
good way to do it, or?
Yeah, I suggest you get a package that already knows how to do it, how to break them down, because EDI is a finicky thing. Having dealt with the the 834s and 837s and all that, yeah, it's a nightmare. And I would suggest using a package to break those down.
If I could expand on that, I've dealt with 850s, oh, geez, it's been too long. Lots of 850s,
Yeah.
and then all the replies to it, get a package.
Yeah. What was
I
funny
mean,
is that,
hands down, bar none. I mean, there's just,
oh yeah, because there's too much to do, too much to keep track of, and yeah, you could always roll your own, but it's not really worth it.
no, hands down, it's not. If you got to spend 20,000 on a string parser, and let's be real, that's what an EDI parser is it's a string
Yep.
parser with rules.
Yep. Exactly.
Do it. We did.
Yeah. When I was in first got into healthcare, I had spent a lot of time in manufacturing, especially automotive manufacturing. So I was already familiar with EDI. And then when I saw healthcare EDI and also HL7, I was like, oh yeah, that's just like automotive EDI. And it's like, oh no, it's very different. Nothing like it at all. Oh yeah, it's the same. You're carrying different data, of course, but the concepts are the same.
Right.
Yeah.
Not having dealt with healthcare, thank goodness, but having dealt with lots of automotive, yeah. Get a package.
And when I started, I worked with a lot of MDs and PhDs who felt that if you didn't have a doctorate, that you didn't know anything, and so it was that was a challenge that I had to deal with.
Hey, another
hate
question.
ring
Are
knockers
you going
like
to
that.
post this video somewhere online where you can watch it again?
Yeah, I have a YouTube channel for the group. I'll post a comment out in the meetup comments for this event for that. I've been trying to get all the videos that we've been taking here recently up there. So yeah, give me a day or two, and it'll Aaron, if you're okay with me posting the video.
Yeah, sure. Just send me the link, and I'll reference that on my website.
Yeah, absolutely. Yeah, so it'll probably take me a day or two to get it converted, uploaded, but yeah, I will post it out to the meetup comments.
Sure.
When I do it.
What's the YouTube channel name?
I think if you just search for Glass,
Glass,
GLASS Glass User Group, you should find it.
All right. Thank you.
Taking a liar out of myself. Go search for it myself. Yeah.
Yeah, I see it there. Yep.
Yep, has a little picture of the glass with Michigan on it. Yep, that's us.
All right.
There's another called Glass Eye Group.
Yeah. Yeah, not the same.
Yeah.
Hey, I have that glass on my bookshelf behind me.
Not the Glass Eye, right?
Correct.
Good. Okay, good.
Yeah, the Glass Eye one, is that about drinking?
But yeah, I will get the
Depends
video.
on your perspective.
Yeah. Any other questions, anybody? If not, yeah, so I think it's, let me double check my calendar for our next meeting, but I think it is the 6th. Let me look at it's gonna be, I think it's the 8th, actually. But yeah, it's already scheduled out on Meetup for our next meeting, and that will be with Case Alter talking on Azure and spinning up SQL Server in Azure. Yes, Wednesday, November 8th at 12 p.m. Eastern. So.
Okay.
And with that being said, you can probably stop the recording now if you haven't already.
Yeah, that's probably a good point. I will go ahead and stop that. So recording and stop.
It's kind of cool that you got that recorded in at the